Today we are going to discuss early effect in BJT. To understand early effect, let's take example of BJT in common base configuration. For CB configuration, input is applied between emitter and base, whereas output is taken across collector and base. This is BJT biased in active region. For active region, base collector junction is reverse bias, whereas base emitter junction is forward bias. In normal working of BJT, emitter will inject electrons into base. Some of these electrons are lost in base due to recombination, and remaining electrons reaches the collector. Amount of electrons reaching the collector will constitute collector current IC. This is output characteristic of BJT. Ideally, these lines which are gradually increasing should be a straight line like this. Okay, ideally this line is a straight line. That means current IC is independent of VCB. It only depends on IE. Therefore, we say it's a current controlled current source in active region. BJT behaves as current controlled current source in active region. However, practically IC gradually increases. You can see this black line gradually increases with increase in VCB. This effect where IC increases with VCB is known as early effect. So let's see the cause of early effect. Now here two parameters or two variables are used. D, which represents width of the depletion layer at collector base junction or base collector junction, and B is the effective width of the base. Effective width means electrical width, not physical one. That is width remaining after subtracting both the depletion layers. So as the VCB increases, reverse biasing voltage across CB junction increases. Due to increase in reverse biasing voltage, value of D, which is nothing but a width of depletion layer, increases. When D increases, value of B will reduce. Here you can see D has increased, due to which value of B has reduced. This effect is known as base width modulation, where width of the base is changing with voltage. So base width modulation. Due to base width modulation, number of recombinations those were taking place into base has reduced. When less recombinations are taken into the base, more electrons injected from emitter will reach the collector. In that case, collector current IC will increase. This effect is early effect. Now, due to early effect, here you can see without early effect it's a straight line like this, and with early effect it's a gradually increasing curve. So without early effect, the slope of the characteristic was 0. Zero slope implies infinite output resistance or output dynamic resistance. With early effect, we get some finite resistance, which can be calculated as VA by IC, where VA is early voltage over here. Okay, and to extend the concept, at certain large value of VCB, if VCB is very large, D will be very large. In that case, value of B might tends to 0. Might tends to 0. That effect is known as punch through effect. Base is being punched out of the system and it results into breakdown in the transistor. Thank you.